We tend to use a lot of surface water around the world, and because of that we have a lot of issues and impacts on surface water systems. In the United States, surface water accounts for about 75% of water that we use, and worldwide it is equally widely used, and that's because surface water is easily accessible and also cheap because you don't have to pump that water out of the ground. So it's important to note though, when we do extract surface water for our own use, and that includes agricultural uses, municipal uses, personal uses, if you have a well in your, not a well, I'm sorry, if you have a river going through your land, or industrial uses, once you remove it from the natural environment, then it's no longer accessible for the natural environment from which it came to be used. So what are wetlands? We're going to talk a lot about wetlands because they are impacted so much by our use of surface water. Wetlands are land areas that are saturated or flooded with water, either permanently or seasonally. And there are three main types of wetlands, and we will discuss examples of each of these three types. These include inland wetlands, coastal wetlands, and man-made wetlands. Inland wetlands are any of the wetlands that are not located adjacent to or connected somehow hydrologically to saltwater systems. And so these would include, I'm sorry, I shouldn't say saltwater systems, but ocean systems. It could be a salty lake, and so then it would still be an inland wetland. But these would include things like ponds, swamps, marshes, fens, estuaries, rivers, tidal flats, and bogs. So here's some different pictures of fens and bogs, and note that non-tidal wetlands account for 94% of wetlands in the United States. So most of our wetlands are non-ocean connected bodies of water, unless you look at the grand scheme of how everything is connected, but in terms of immediate connections they are not. And so they are mostly freshwater, although there are some salty lakes. If we want to talk about coastal wetlands, these are wetlands that do have some connection to salty ocean water. These would include marshes, estuaries, coral reefs, which is what's pictured here, and lagoons. So these are all bodies of water that have that are wetlands. Sometimes, some parts of the year, they may not have as much water as others, or for coastal wetlands, when the tide goes out, some of that land may surface, and when the tide comes back in, then it will be underwater. When we talk about man-made wetlands, the two main examples that we think of would be rice paddies and fish ponds. So these are two examples of man-made wetlands, and they can be extensive and they can be important for wildlife. So even though they're man-made, that doesn't mean that they don't have environmental benefits. So why do we need wetlands? Wetlands, there's many things that wetlands do. Wetlands are helpful in resupplying aquifers, so you can recharge groundwater systems through wetlands. They're also important for food supply, especially when we're talking about those man-made wetlands, especially for fish and rice. And rice is especially important because it accounts for about 20% of the world's food. Wetlands are really good at purifying and filtering water to remove pollutants, and this can include agricultural chemicals. So when water is flowing off of a field into a wetland, that can help get rid of some of the phosphorus, for example, or nitrogen, excess nutrients that's in the runoff water. It also can help remove heavy metals from mines and other industries, and it can help to purify and filter human sewage. And that's especially important in countries where they don't have great systems for containing sewage to keep it from getting into natural waters that are then used for consumption. Wetlands are also very good for storing water, which seems pretty obvious, but that's important because we need to be able to store water for times when water isn't as available different times of year. And they also help to prevent soil erosion. Wetlands help prevent floods because they can store a lot of water, so they can soak up that water like a sponge when it rains, and so that prevents water from flooding out of river systems, for example, and backing up. And then finally, they are biodiversity hotspots. There are lots of animals and plants and just bacteria, fungi, lots of organisms that rely on wetlands and that live in wetlands. So because we know wetlands have so many benefits, when we think of losing wetlands, there's a lot of benefits that we're losing. And it's important to note that we're going to talk mostly about losing wetlands, but even if a wetland is intact but it's been contaminated too much, then we're essentially losing many of the functions of that wetland. So how do we lose wetlands? We can lose them to water diversions. So we've talked about dams and canals. If you divert water away from a wetland, then it's not going to recharge with water and it will dry up. Wetlands also often are drained or filled for agricultural use, so to grow crops on that land or to grow trees. And also we pave over wetlands sometimes if we need to put in a road somewhere or a mall, whatever. Lots of different reasons we would pave over a wetland. So because of all of these different ways that we lose wetlands globally, we have lost 64% of all wetlands since 1990. And if you go all the way back to 1700, globally we've lost 87% of the wetlands that have existed and did exist on Earth. If we look at the United States, we've lost more than half of our wetlands by 1984. In 1985, there was wetland conservation passed that significantly slowed the loss of wetlands, and so we kind of stopped that loss in 1984, and that's why our numbers are looking better than the global numbers. This is data for the United States. So this is showing what we're losing wetlands to in the United States, and the green part of the pie is silviculture. That's for cultivation of trees, so a lot of it's being lost and filled in so that we can grow trees in that land. Agriculture is another big piece. Other land uses, I don't like it when they put that category in because what does that mean? And then development, so paving over areas. Okay, so if you look at this chart, this is wetlands lost in the United States from the 1950s to 2009. I like this chart because it shows the impact of the legislation that was passed in 1985, which prevented loss of wetlands. And so you can see before that the rate of loss was very high. We were losing many, many thousands of acres of wetlands every decade. And then when that legislation was passed, all of a sudden that rate of loss went to almost zero, and in some cases there was an increase in the amount of wetlands. It is important, though, to note that the law that was passed in the United States does not say that you can't do something to a wetland. It just says that there's no net loss of wetlands. And so if you need to fill in a wetland in one area so that you can build a road through it, then you have to create a wetland somewhere else. So sometimes we can lose a wetland that's a high value wetland and then put in a lower value wetland, something that may not aid as much in biodiversity, but at least we are recreating wetlands somewhere else, and so we're not losing them at the rate that much of the world is. Other human impacts on surface water besides loss of wetlands, when we talk about estuaries are also impacted when you divert water through dams. An estuary is a unique type of wetland. It's an area where you have a bay or a river delta region, so you have fresh water coming in and it's mixing with salt water as that comes into the ocean. So fresh water is flowing out into from a river at this big delta where the river spreads out, and then it's connected to the ocean there, and that fresh and salt water mix. This area is really a really great breeding ground for fish and waterfowl. But as less fresh water is coming down through the river because of diversions, then less fresh water is entering that system, and the water tends to become saltier and more dominated by the ocean water. And so it's not as healthy for the life that is accustomed to living there, because it's getting saltier and they're just not used to it. So one animal that's being affected by this are great egrets. They nest and breed in estuaries. This is a picture of a great egret, and as a result of the habitat decline, their populations are declining. So to get to kind of a more international look at wetland loss and surface water diversions, we'll look at a classic example, which is Lake Chad in Central Africa. Lake Chad has shrunk to one-tenth of the size that it was in 1973. So in just 45 years, we're looking at a 90% decrease in size. There's a couple of reasons for that. So often people talk about just dams, but there's many reasons actually for this loss. One issue is climate change. So that in years where they're seeing less rainfall, this lake is shrinking faster, and so Lake Chad, the shrinking of Lake Chad has definitely increased as we're seeing less rainfall due to climate change. There's an increasing population in the region, and so there's more demands on the water, and as a result there's more diversion of water upstream, and that water is being used for irrigation and for human use and consumption. And so as a result of all of these different impacts on the lake, it has shrunk, and you can see the blue area on the lake here is the water, the extent of the water surface in 1973, and then in 2017 it's just this little tiny area down at kind of the bottom right corner of what was the lake. And so there's still green because there's still some water coming in, but it's just not a lake anymore in much of that area.